My name is Vladimir Bulovic. I'm an associate professor of electrical engineering here at MIT. I'm a nanotechnologist. My work is in understanding how to use nanostructured materials to make practical devices for everyday applications. The world around us works on a nanoscale, and our job as technologists and scientists is to understand how to tame the nanoscale, how to control it, how to understand the insights that it brings us. Past decade has been amazing in allowing us to fathom the ways that the nanoscale works. The atoms are put together, the molecules are put together. And with that, we are now learning what are the primary units that make a transistor, that make an LED. You can use a variety of very small items, molecules, quantum dots, nanostructured solids, and make fantastic amount of devices that we now today use as given to us. RLE is an amazing entity in providing a gathering place for many of us. What gets me going, or what might make me choose a project, is how well do I get together with a faculty that just proposed this really interesting idea that I know how to do, that they know partially how to do as well, and together we can really do it properly. I am an electrical engineer, but at the same time I find myself without boundaries on being able to easily approach chemical engineers, chemists, material scientists, people who indeed you would think are not in my discipline. And that's because of this place. It's very, very, very easy to interact. Nanotechnology works on a nanoscale. For us to understand the laws that govern nanotechnology, we need to understand a good deal of science. I'm an engineer though, so my job and my passion is to make gizmos, to make things that do this and that. Well, those gizmos work because of the physics. If I can make a gizmo that's functionally useful, but at the same time serves as a really good test bed of physics, that's the perfect gizmo. That's the one I want to play with. From that gizmo, I'll learn so much that I can make 5 new gizmos down the line that again do something very cool because I just learned a new physical principle, or I just learned a new way of assembling matter that has not been noticed before. Teaching for me has many aspects. I'm extremely passionate about teaching. One of the things I feel very strongly about for electrical engineers, or engineers in general, is that we need to appreciate the connection between the science and technology. By being able to show them practical, everyday electronic applications, consumer electronics you can think, and recognizing that in that consumer electronics there is very deep, very simple, very approachable physical phenomena that they often have not even thought of, and realizing that these physical phenomena they can be manipulated in a fantastic number of ways. I think we're generating students that are much more savvy about the next thing they learn, the next equation they step in their junior year or senior year. I would like to be able to think that what we generate beyond just generating knowledge is generate the next generation of leaders, people who are capable of telling us what are the new inventive technologies to pursue. By no means do MIT professors know everything, but the one thing I think that we do know what to do is we do know how to inspire students into being the next leader. Indeed, our greatest source of innovation are our students. Without my graduate students, I wouldn't be able to accomplish half the things that we set upon to do. Since I joined MIT, I've opened my eyes beyond what I have ever imagined. We are using new material sets, we're using new material growth methods, and we are able to manipulate the nanoscale much more than I've ever envisioned stepping into the MIT. A success to me defines being able to invent new ideas and being able to graduate students that will land jobs that will make a difference to the world outside. I love coming to this job every day because every day is exciting. Every day is new, every day is different.